In Tucson, Arizona, the number of hours of daylight on day t, where t is the number of days after December 31st, is modeled by the function L of t equals 12.1 plus 3.2 sine of the product of 2 pi divided by 365 and t minus 80. Which days of the year have at least 10 hours of daylight? Solve by graphing and round to the nearest whole number. I've already set this up using Desmos. The first step is to enter L of t in cell 1 and L of t equals 10 in cell 2. By clicking on the wrench, you can see the window I used to display the graph, and also notice I am in radian mode. For the next step, we'll determine the t values of the points of intersection, and then we'll figure out which days of the year these correspond to. By clicking on the points of intersection, the order pairs appear. Rounding to the nearest whole number, we have t equals 38 and t equals 304. T equals 38 corresponds to February 7th. T equals 304 corresponds to October 31st. Let me show you the table I used to determine these dates. This table shows the days of the year numbered from 1 through 365. Notice we have the months along the top. Notice t equals 38 would be February 7th. The month is in the top row, and then the day of the month would be in this first column. And 304 corresponds to October 31st. This indicates February 7th through October 31st have at least 10 hours of daylight. For part B, how many days of the year have at least 10 hours of daylight? To obtain the number of days, we determine the difference of the t values and then add 1. This gives us 304 minus 38 plus 1, which is 267. Now the reason we're adding 1 here is because remember, if we had 10 days numbered 1 through 10, 10 minus 1 is 9, we'd have to add 1 to get a total of 10 days, which we know we have if the days were numbered from 1 through 10. So the difference plus 1 is equal to 267, which indicates there are 267 days with at least 10 hours of daylight. I hope you found this helpful.